Good day, students. I is emergency vacation. And here I'm Mr. Akínpẹ̀lú K.O. from GNA Schools, Ayọ̀bọ̀, Lagos. I'm here to have you SS3 practical physics. And the part of SS3 practical physics we are having you is electricity. And under it we have the potentiometer. This is the setup, the diagram setup for the potentiometer as the question requires. Now in the circuit check up here, you have the circuit connected according to the instruction, and we have to connect it according to instruction. If we don't connect it according to instruction, we get the wrong result and wrong value and deduction. Now we see the wire from the P here connected to that of the resistor and to the battery. Battery is what? The connection of two or more cells together. This is in series. And we have the jockey here and the ammeter, and this is the potentiometer. Okay, now we start according to the instruction. First of all, what is the number one? It said connect the circuit as shown in the diagram above. That is the connection of the circuit we have already done. Now number two, with the jockey and J not making contact with P, that is the potentiometer. Switch on the key and take the reading of the ammeter. Record your value I. Look at what I have here. Without the jockey making contact with the potentiometer, I will have my readings here. Here I have 0.4 ampere. 0.4 ampere. I will record it. That is my first record. I is 0.4 ampere. That is, you have to record it. It's part of what the examiner is looking for. Now the next one, the third one, use the jockey, make a contact at the 20 centimeter mark, close the switch, read and record your value I on the ammeter. We read and record that value I on the ammeter. Now let us take 3, 4 together. Repeat the procedure for the values L, 35 centimeter, 50 centimeter, 65 centimeter, and 80 centimeter. In each case, determine the corresponding values of Li and II is for the current. Now what I will do is that I will draw a tabular from here. This L is in centimeter, I is in ampere. Now we have the first one 20, the second one is what? 35, the third one is 50, the fourth one is 65, and the fifth one is what? 80. Remember, you can have 4 or 5 or 6 experiments to value. You cannot have one. You cannot have one. We have 5 or 6, so that when we take the value, we get an average reading or almost to accurate result. We are able to tabulate our reading. Then I will start from 20, 35, 50, 65, 80. Now then we have with the contact here, I have the 20. This is 20. This is 20. I have 0.85. 0.85 here. 0.85. That is what I have here. Then I have for the 35. For the 35, we have on the 35, I have 0.8. 0.80. Now for the 50. For the 50, we have the 50 here. 0.75. 0.75. Then the experiment goes to us like that until you reach the end of the experiment. We have the next one is 65. 0.7. That is 0.7. I hope you are getting along in here. And if you look at it as I'm increasing the length of the potentiometer, the value of the current is what? Decreasing. And let us look at 80. We have 0.65. 0.65. Okay? Now, what we do is that we make a proper tabulation. After you have two tablets, don't write it in your what? Question answer sheet immediately. This answer sheet. Then you transfer this also into a bigger one. I have something like this. This serial number. Experiment 1, 2, 3, 4, 5. Remember, our I is what? 0.4 ampere. Now this L centimeter and this I ampere. And you look at here, plot a graph of L, inverse of L. That is when we say inverse of L, that is 1 over L. 1 over L. Okay, you put that one in mind. What will be this value? This value will be inverse of centimeter here. Okay, per centimeter. Now the first one is 20. The second one is 35. The third one is 50. The fourth one is 65. The fifth one is 85. Okay. Now when we have 20, we have 80 here. In 20 we have 0.85. Okay. In 35 we have 0.80. In 50 here we have 0.70. And we have 65 here. This is 75. 0.70. And in 80 here we have 0.65. Okay. Now we have inverse of here. Inverse of 20 is what? When you press inverse of 20, we have 0.05. Okay. When we press inverse of 35, 0.029, which is okay. Now 50, inverse of 50, 0.020. You see that this 3 decimal place and have to follow suit. 65, 0.016. Okay. Now for 0.15, yeah, 1.5. Now for 80, 0.010. 1 3. Look at the tabular form, then we now transfer it to the graph. This will be on the vertical axis, while this on the horizontal axis as we see it, and we are starting from 0, 0, that is x is 0, y is also what? 0. Are you getting me? Now from here, look at it. Now in your graph, you have to be very careful. You have to be very careful. Now first of all, of our graph, type of our graph is what? Graph of against what? I. That is the title of our graph. Don't say graph of potentiometer. No. Graph of average power against I. Now we come. What is the highest in the horizontal? The highest is 0.85 here, and the lowest is 0.65. Both of them are what? Are under 1. Are under 1. What you do, you number your what? The thick line here. In my own thick line, I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Yeah. Okay. Now this is what I number here in the horizontal axis. Now in the vertical axis, what is the highest? 0.05 is the highest. The lowest is about 0.015. Are you getting me? Both of them still under 1.0. You have to spread your what? Your value to the highest here. And mind you, you have to take 75% of the graph. 75%. Don't take 25% like this. The time is almost 70. Covering almost what? The entire graph. Now 75% of the graph, what we have is 0.5. Let me check. If I have in my drawing here, if I have 0.1 here, 0.2, 0.3, 0.4, 0.5 here, you see that it's very tiny compared to the entire diagram I have here. Okay? Now, looking at it, I spread it again, let's say 4 centimeters for 0.1. Because this one is 2 centimeters. 4 centimeters for 0.1. I have 0.1, 0.2, 0.3, 0.4, 0.5. Okay? Now, that is it. After getting that, you are now halfway done. Then let us start how we have done. Now, if we have 0.85 here, then we have 0.50. We have 0.5. There's one thing I want you to notice that either we have this point or this mark or this mark. Please, these are the correct one, acceptable one, but there should be nothing like this. It's wrong. This is wrong. Okay? These are the correct one you can apply on your graph. Okay? These are the correct one you can apply on your graph. Let us 0.85. This is 0.85. This is 0.8, 0.9, 0.85, 0. And this where is my 0.85 is. Then 0.5 here on the vertical. Now trace it. You have to be very careful. You can trace it with your ruler so that you don't get confused. Look at it. This is 0.85 with 0.5. The next one is 0.8. 0.8. 0.8. This is 0.8 and 0.2, 0.025. Okay, now you have to be very careful times 10 raised to the power minus 5. If I say 0.05, 0.04, 0.03, that means there's no need of times 10 raised to the power minus 1 here. Okay, now we have 0.029. This is 0.029 here, and we have 0.8 here. Okay, now the next one is 0.75, and we have 0.2020, which is somewhere 0.75. And the next one is 0.7, yeah, which is 0.15 here, which is coming to here, which is 0.7. The next one, the last one is what? 0.65, and we have 0.13 here, and this 0.13. The next one, okay, that is 0.65 here. Now, looking at that, you see that you want to draw a what? A best fitted line. Best fitted line. Please don't rush when you are drawing your best fitted line. Try to check which of the what? The line falls. If I have something like this, leaf fall here, you see some of the line, the point falls here. If I have something here, you see some of the point falls here, some falls here. I get it. If I have like this, you see majority of the point falls here, falls here. You draw the best fitted line, which is something applicable. You can try to know, you see 2 here, 2 here. Now, you see something like this. And we have another one, something like this. The 2, you have to use your discretion to draw your words. Your line. And do not copy. When you copy another one's work, that means by the time you are writing your calculation aspect, the gradient, the slope, everything will be wrong. You have to do what? Now, look at it. You see that in my own 2-4 here, 2-4 here, but you see this one is far away from the what? From the and looking at it, we want to look at the next step we have after drawing the what? Graph. Now, the first one from the graph, deduce the value of I1 when L raised to the power minus 1 is what? 0. I0 of what? I1. When L raised to the power minus 1 is 0. This L raised to the power minus 1. When it is 0, where it is I0. You have it here. What do you have here? You have 0.5 what? 56. This is our value here, okay? That means I0 is what? 0.56. Now you write it here. What you write it on the graph, you write it on the part here so that when the examiner is searching for it, you'll be able to identify it. That IO is what? Is 0.56 ampere. I put the value. You have to put the unit. Failure to put the unit is 0 mark. Now, evaluate IO and I1. Evaluate. IO is what? 0.56. I is what? I is the one we have what? 0.4 here. From the first reading we took, which is 0.4 ampere. We now have I is what? Is 0.56 divided by 0.40. Yeah. Okay? Now, what do we have? We have 1.4. Is that the answer? Yes. But somebody will ask, is it not, will there not be a value? There is no value. This is ampere. This is also what? Ampere. Ampere times ampere. That is no unit here. The final answer we have what? 1.4. Now, the fifth one, state 2 precautions taken to ensure accurate result. What are the precautions when you are what? Connecting your circuit and when you are reading? I ensure that the connection are well according to the diagram. That means if you do not connect it according to the diagram or the instruction, you get wrong value. The second one, I ensure that the connecting wire are tightly connected. I will give you 2 more, then you give me another 2 more. On the whole, I ensure that I open the switch when not in use to avoid unnecessary wastage. It will be going down as it is, it will be really going down. The third one, I avoid error due to parallax when checking my reading. And look at it, the graph. Now, can you tell me that, and in your graph also here, ensure that you write the title of the graph, then you write the scale of your graph. Is there any very essential? You write the scale of your graph. At the end, you write the scale here. I will leave it to the student to write their own scale, and that is it. And you ensure that everything is well. If it is everything well, then you are what? Planning for success. Thank you, and God bless for the short time you have. have